Alright, this problem is a little more complicated. So when you read this, what massive solid ammonium chloride is formed, that's key, when 73 grams of NH3 are mixed with an equal mass of HCl. So the fact that there's a formation here tells you that this is not truly a mixture, it's actually a chemical reaction. So because this is formed, that's going to be at the end of my equation. It's also important to note that it's a solid, so when we're looking ahead, you're going to see there's some gas law properties coming up. And then I have NH3 plus HCl. Okay. These are both gases, or can be gases. HCl could be an acid if that gas is bubbled through water. And I have equal masses, so I have 73 grams of each. Well, grams don't react, moles react. Okay. When I read ahead in the question, what is the volume of gas? That's what I need to find. So volume, when the conditions have been controlled to be 14.0 degrees Celsius, which is my temperature, and 752 millimeters of Hg pressure, and then what gas is it? So one of them is going to remain. So this is a solid, so this is not your product, it's one of your reactants. So I have to figure out, and it really doesn't matter which one you start with, I'm just going to start with the first one, which is the NH3. I have to figure out how many moles of HCl do I need for every mole of HCl. The other thing you should always check with an equation is it balanced. So I have 1 nitrogen to 1 nitrogen. I'm going to skip hydrogen for right now. Chlorine, 1 and 1, and then hydrogen, 3 plus 1 is 4. If I have to change something with the chlorine, it'll change my hydrogen. That's why I skipped that one. So I'm going to figure out how many moles of HCl do I need to use up all 73 grams of this. So I'm going to use the molar mass of NH3, so going to the periodic table, I'm going to get the nitrogen, 14.01, and 3 times the hydrogen. And then I'm going to use the stoichiometry of the equation. You must show this, even if it's 1-to-1 on the AP exam. So 1 mole of ammonia is 1 mole of hydrogen chloride. When I calculate that, I am going to get 4.28 moles of HCl. Then I have to figure out how many moles of HCl do I really have. So think of it as a recipe. You're going to your cabinet. Do you have enough of all your ingredients? So this is HCl, and I need to know moles of HCl. So this will actually be a shorter step. I just need to convert this one to moles. So again, hydrogen 1.01, chlorine 35.45. So adding those together gives me 36.46. And this is going to give me 2 moles. Okay. So what this tells me is I'm going to use up all of this first. So this is less. So this is what's called the limiting reagent. And we'll do a little bit more with that. I usually do stoichiometry and equations before gases. So this is why this is a little out of place. But it won't hurt you to see it now and see it again later. So I'm not going to use up all 4.28 moles of HCl because I don't have that. So then what I need to figure out is how many grams of NH3 do I need to, I have left over. So I'm going to start with my 2 moles of HCl, and I am going to figure out how many grams of NH3 I have left. So there's 1 mole of HCl for every 1 mole of NH3. And I'm going to go back to grams. 1 mole of NH3 is 17.04 grams. So 2 times 17.04, that one you really wouldn't need a calculator for. So 34.08 grams. So this is how much is used. So it wants to know volume remaining. Oh, so sorry, no, we don't even need that. We can just stop here with moles. So we're going to have 2 moles of NH3. Sorry, since this is a 1-to-1, you're going to use 2 moles of HCl for every 2 moles of NH3. So if I just come back here and calculate how many moles of this is, sorry, that's why I grabbed the calculator. I have myself here. So this is also going to be 4.28 moles. So I'm going to have 2.28 moles of NH3 used, or given, and only 2 moles of it used. So I'm going to have 2.28 moles of NH3 remaining. Okay. So I know moles, I know temperature, I know pressure, so I can find volume. .0 plus 273, I'm sorry, I'm running out of room here, all over my 752 millimeters of Hg. And again, since I use the liter atmosphere, I know that's my kind of go-to for that one, that is going to give me 54.3 liters of NH3 remaining.